Utilities typically specify voltage imbalance limits at the meter or service entrance. These limits vary widely, but 3% unloaded is not uncommon. However, the Institute of Electrical and Electronics Engineers Standard 519 recommends limiting voltage imbalance to 1% or less at the motor terminals for proper motor operation and efficiency. There are several potential causes of voltage imbalance on your side. Firstly, unbalanced loads. Heavy loads connected to one phase can cause imbalance. Secondly, transformers. Delta-connected transformers can introduce voltage imbalance if the loads and the phases are not balanced. Thirdly, faulty wiring. Loose connections, damaged conductors, or poor quality wiring can contribute to voltage imbalance. Fourthly, unbalanced capacitor banks. Capacitor banks used for power factor correction can create voltage imbalance if they are not properly sized or connected. The 1% voltage imbalance limit specified by the National Electrical Manufacturers Association is based on a balanced load. The current imbalance may be exacerbating the effect of the voltage imbalance on the motor. The Institute of Electrical and Electronics Engineers white paper suggests that 2 to 3% voltage imbalance is acceptable for certain types of motors, but it is not universally accepted. The Department of Energy and other sources generally recommend keeping voltage imbalance below 1% for optimal motor performance. The fact that only one of the two feeders is experiencing problems suggests that the issue may be related to the feeder itself or the loads connected to it. Here are some recommendations. Firstly, contact the utility to verify the voltage imbalance limits at the service entrance. Secondly, check for any unbalanced loads, especially on the feeder that is experiencing problems. Thirdly, inspect transformers and wiring for any faults or imbalances. Fourthly, consider balancing capacitor banks if they are being used for power factor correction. Fifthly, consult with an electrical engineer to further investigate the voltage imbalance and identify the best solution for your specific situation.